be doing screencast with commentary of this third division round. Assuming that my internet allows me. Or maybe could first, I'm not sure. Who's to blame? Not me. I didn't do anything. Come on. That's a lot of problems. You already got accepted, I just can't even open the problem yet. Okay. What? Print and divided by 4 rounded up? Okay. I can do that. Amazing problem. I even have a pre-written function for it. I will save so much time. Problem B, square grid and by n of zeros and ones wants to reduce grid by factor of k. K must be a divisor of n. Split the grid into k by k blocks. Places each block in a single cell. It is guaranteed that every cell has the same value. So I just need to do exactly what is written here. Okay, sure. Really? That is what third division problems like. Okay. Well, if you think so. The hardest part of this problem is to actually read all the grid. Okay, so I want to iterate with step of k by both coordinates and then print what's there. That's what the statement said, right? You read the input and then iterate not with plus plus but with plus equal k. That's an interesting problem. Okay. Sure. Problem C. Have two strings of length n. First, against your will to answer Q queries. Yeah. Every day I wake up against my fucking fucking wheel. Yeah. Which query given a range, can choose an integer, like an index inside that range, and set AI equal to x, where x is any character. Put the minimum number of operations. Must perform the sorted of that range is equal to sorted of that range over array B. Okay, so sorted equals sorted, it means that multi-sets are the same. So I hope that characters are small, lowercase Latin letters. Yeah, I actually don't know how to solve it if the alphabet is big enough. I don't know, probably impossible. So, okay, well, we have just 26 letters, so for every letter we will count prefix sums of, like, the number of appearances of that letter on prefix, which is done by replace each letter by 1 if it's this letter and 0 otherwise, and then calculate prefix sums on that. So we do this for array A and for array B. Actually, we can calculate the difference of them right away, but well, to save space, it's kind of not a bad idea. Right. And then when we have query, we just calculate how many appearances of every character is in array A on that segment by using our array of prefix sums. The same for array B. And then in every operation, we can take some character, take appearance, an appearance of that character, and remove it while inserting an appearance of some other character. So we want the counts to be the same, so we will take some numbers that is greater than we want it to be and decrease it by 1, and some other numbers that is smaller than we want it to be and increase it by 1. And so the number of operations is like sum of absolute values of differences of counts in array A and B divided by 2, or you can just like calculate by how many in total we have an array A bigger counts than in array B or smaller. They should be equal. And they're both equal to the answer, because like you need to reduce the ones that are bigger and increase the ones that are smaller, and in the end they will coincide. Or if you just take absolute values, then you take the ones that are bigger plus the ones that are smaller, and you get twice the answer. That should be it. And so yeah, since I'm already I'm only looking at the differences of counts in A and B, I can just calculate the prefix sums for differences right away, or like differences of prefix sum, which is the same thing. And that will save like half of the memory and half of the time, I guess. Well, I mean, no, I'm just doing those operations earlier. It doesn't really matter. Well, you shouldn't try to optimize before. I will just do it like that because it's cooler. It doesn't matter if your algorithm is like better, faster, has better complexity. If it's cooler, it's a good enough reason for me. So I need to clear the arrays. Okay, that's not how I would normally write this, but since I only have one array and I want to calculate prefix sums from two things, I guess I will first create those arrays actually, but I want them to be in one indexation. That's why it's I plus one here, because that's how I want my prefix sums to be. Like prefix sums should be not inclusive. Prefix sum of p should be the sum of elements up to p not inclusive, because I want to be able to have 0 as my left border. I want to know like what is the prefix sum up to 0's position not inclusive. It's obviously 0. I haven't added anything. But then when I will calculate the sum on segment, I will take sum on right border minus sum on left border. And if left border is 0, I want this to be a valid prefix sum, so I don't have to write an if separately. So yeah, if you're calculating prefix sums inclusive, that's wrong, and you should stop doing that and calculate them not inclusive. So yeah, array I plus plus, array B minus minus. So I'm taking the character, and in the array corresponding to that character on position I plus 1, making plus plus and minus minus, then calculating prefix sums. They are not inclusive, so pref of ci is prefix sum in the array corresponding to character c up to position I, but not inclusive. So if I is equal to 0, it's just for an empty prefix. If I is equal to n, it will be for the whole array. And now answering the queries. Hi boy. To answer the queries, I'm taking the sum on corresponding segment for this character. No plus minus ones. No. I mean, there is minus 1 here because I want the segment to be half interval actually, left border included, right border not included. L and R were given in one indexation, so I want to move them to 0 indexation, but right border should be not inclusive. It should be after the segment. So I'm kind of doing like L minus minus, R minus minus, but R plus plus. Minus 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 to make it 0 indexed. And then plus plus because I want it to be after the segment ends. So it's just L minus minus. And if I have a segment like this, then to calculate the sum on the segment, if I have prefix sums, just taking prefix sum in R, like after my segment ends, minus when it begins. So what was the sum on prefix before the segment end minus before it started. So what is left is what's in the middle, what's inside the segment. And I don't have to write any cases when left border is in 0, is in the beginning of the array, because this is a valid prefix sum. It's prefix sum of empty prefix. Yeah, and here I said like you can like write if it is positive then add it to answer, for example, or you can add absolute value of that x to answer and then divide answer by 2. Problem D. Two integers n and x, find the number of triplets a, b, c of positive integers such that ab plus ac plus bc is at most n and a plus b plus c is at most x. Have 10,000 test cases and n and x up to 10 to the 6. It is guaranteed that the sum of n does not exceed 10 to the 6, sum of x does not exceed 10 to the 6. Okay, so we have positive integers, so they're at least 1. So this is obviously bigger than this, or like not small. So what's important for us probably is that sum of n is small enough, and so we want to well, we probably want to just write brute force, I would guess. Yeah, if I just iterate over a and b so that ab is at most n, that obviously must be true. Then for number c I will have two inequalities. One from here, I will combine these two and get that c should be at most n minus ab divided by a plus b. And from here I know that c is at most x minus a minus b. And so the number of such c is obviously calculated. Just minimum of those two borders rounded down, and that's it, except that if it is smaller than 0, it's still 0. And so that will work in time proportional to what is the number of of pairs a and b such that their product is at most n. And that is well known to be of n log n. The proof is sum of the harmonic series. Like if you fix a, then the number of corresponding b's will be n divided by a rounded down, and if you don't round that down, just write that sum, you will get n times sum of like multiplicative inverses of numbers 1, 2, 3, and so on. So 1 divided by 1 plus 1 divided by 2 plus 1 divided by 3 and so on. And that is well known that the sum of first n elements of that sequence is of log n. And since we know that sum of n is at most million, then that whole thing works in million log million thing. I'm pretty sure that the answer to this problem should fit in integer, but I will not check it. I mean, it's obviously at least n square root of n because, well, if all a, b, and c are smaller than like square root of n divided by 2, then this is at most n times 3/4. So we get at least n square root of n divided by 8. And I think that should be like more or less the correct approximation. But I will not. I will not check it. I mean, we can just run on million and see if the answer fits in integer. But let's first write the solution with long. Since I put both of these inequalities in the condition of for loop, C here must be non-negative, right? This is non-negative, this is non-negative, and then I divide by something positive. So C is non-negative, so I don't have to take maximum with 0. That's it. Okay. That is just above 2 billions, right? Yeah, so it fits an integer. But it should be fast enough anyways. But it would be a funny joke to make limitations so that it just slightly doesn't fit in integer. Yeah, people would hate them. But I think it's a funny joke. Because like you should always check that the integer type you're using is big enough to fit all the calculations you want to do. And like if you didn't do that, it's your fault. Problem E. This is how you do bullshit. You get an array for your birthday. Like, write it as an what is it called? Epigraph? Something like in a different font, so that people know that it's not a part of the problem. And yeah, something to get a waifu, blah blah blah. In order to decode it, you must solve the following problem, and then there is a problem without all that bullshit. That's good. That's good statement, right? I understand the wish to add some jokes into statements. It shouldn't come in the form you got an array for your birthday. Okay, we have a binary string length n for every segment. Count the number of subsegments. The amount of zeros equals the amount of ones. Output the sum of counts over possible R. Okay, so you choose LR, then count the number of pairs X, Y, and then sum it all up. So actually you're calculating like 4 tuplets L, X, Y, R, like it's written here. And whether the 4 tuplet is good depends only on X and Y. So actually you look at the segments XY, and if this thing is good, you add number of ways to choose L on the prefix before X times number of ways to choose R on the suffix after Y, which is like if we have X and Y in 0 indexation, it will be like X plus 1 times N minus N plus 1 minus Y. And obviously I want to call them L and R. Okay. So we have a string, segment. If the segment is good, we need to add to answer L plus 1 times N plus 1 minus R. If they're in 0 indexation and they are half intervals, as all normal people would do. Right, and good means that number of zeros is the same as number of ones. If you just have zeros and ones and you want to look at like balanced strings in the sense that they have the same number of zeros and ones, you want to, for example, change zeros to minus ones, and then the segment is good if and only if the sum is 0. So we change 0 to minus ones, and then if sum is 0, then we add this to the answer. Sum is 0, we are looking at the segments, so sum will be difference of prefix sums in left and right border. And so this condition is the same as the prefix sums are equal. And so we calculate the prefix sums for all the borders. Then group the borders by the value of their prefix sums. And now for every prefix sum, we have some borders, such that if we choose any 2 borders, they will give us a good pair. So now for fixed value of prefix sum, we have some set of borders. And we need to add to the answer sum of over all the pairs well, this, so it's like bi plus 1 n plus 1 minus bj. Well, here you have different options how to proceed. One option would be to try to make this symmetrical. Like right now we have the property that I should be smaller than j. And so we cannot just say, okay, we have like two sums and we sum the products of something depending on I and something depending on j. So it's just sum of those guys times sum of these guys. That's not true. And probably it's not very easy to symmetrize here. But you can just say that, like, if we, for example, fix I, then this thing is fixed, and we will get and when we iterate over I, we can maintain the sum, and then for every I, just multiply bi plus 1 by the sum and add to answer. That would work in linear time, and we need to do it modulo something. I was worried about that part because like the answer is of the order n to the fourth, so it doesn't fit in long, but yeah, just modulo something. Instead of doing this, I want to kind of do it online. So instead of grouping by I, we can group by j and maintain the sum of bi plus 1 for the ones on the left. And then we can just go through the string, maintain the current prefix sum, and for the new border, we're like, okay, we have a new border with this particular value of prefix sum. We know the current sum of bi plus 1 for this value. Add the product to the answer, and then add this new value to this sum. And then we don't need all the vectors, nothing. Because I change zeros to minus ones, prefix sums can be negative. To avoid that, like I want to use prefix sums as indices in the array. So to avoid that, I will start prefix sums not from 0, but from something big enough so that they will never become negative. For example, we can start with n. Then like, for every element we will change our current prefix sum by either 1 or minus 1. So all the prefix sums will stay from 0 inclusive to n inclusive. So I need to clear this array only up to 2n, but inclusive. So to answer, I need to add a of x multiplied by n plus 1 minus p, and then add p plus 1 to ax. It's interesting that that message is in Russian. Like, I'm on conforces.com, I'm using English interface. Why that sync is in Russian? I mean, I understand that it's external, but how does it know that I speak Russian? Problem F. Have two arrays A and B of length n, score is 0, in one operation you can choose integer I and add AI to the score. And then you set AI maximum from 0 and AI minus BI. So basically I'm choosing some position, getting AI from it, and then decreasing it by B, but taking maximum with 0. All the b's are non-negative. You only have time to perform k operations. What is the maximum score you can acquire after k operations? Okay, since all the AIs are non-negative always, I will perform all the k operations, but I don't have to. if I choose to not do it, then it's okay. But then we don't have to take maximum with 0. Because well, if I get negative values, I will just not do operations with set I. Okay, so if k was smaller, one way to solve this problem would be to just greedily choose the largest AI every time and use it. Why is that? Well, because if we don't use the biggest AI at some point, and like we never use it afterwards, we can replace the last operation with choosing the greatest AI, which is not worse. And yeah, the order of operations doesn't matter in the sense that well, operations with different indices do not change each other. Operations with the same index do change each other, but it doesn't make sense to swap them because it doesn't do anything. So for the same index, you just do the first operations, then the second, then the third, and so on. And so if you do the operation with index I this time, where d is 0 indexed, I guess, then you decreased a by b d times. So you will get ai minus bi times d. Right. I'm kind of lost in my explanation. I said that just doing the greedy is good. I think I proved it. Now we need to figure out how to do the greedy fast enough. And to do that, we will notice that if we follow the greedy, after we do some operation, the AI will decrease for the number. And so we always choose the largest possible AI, and then it becomes smaller. And all the AIs in the process of doing our algorithm will become only smaller. They will never become bigger. And so the largest of AIs will also become smaller with every operation. So the scores that we are getting will follow this downward trend each time. I mean, it monotonically decreases, well, not increases. And that means that if we basically we will get all the operations with score like a billion, then all the operations with score billion minus 1, billion minus 2, and so on, until either we reach 0 or we just run out of operations. And so we can try to understand when will we stop, at what value will we run out of operations. To do that, we need to understand how many operations we can get that will have like score increase larger than given value. And well, that's pretty simple. For every index, we just need to understand what was the largest D such that AI minus BI times D is still not less than the boundary that we fix. And then if we implement such function, which works in linear time, we can do a binary search on the border when we stop. So we want to find what is the value x such that we have less than k operations that has strictly greater than x improve, but if we allow like, not strictly greater than x, so like greater or equal to x improve, then there will be at least k such operations. We can find that x with a binary search. After that, we will understand at which position we will stop, and then we need to calculate the actual score. We know how many operations with exactly x we will get. That's k minus how many operations with strictly greater than x we did. And what's left is to calculate the sum over all the operations with strictly greater than x. And that's like for every I, again, we need to calculate the sum of all those AI minus BI times D for such D that is greater than x. And that's just like sum of some arithmetic progression that we can do easily. I have to say, I do not understand the division system of cut forces. Like, when I started, there was just first division and second division. That was okay. Now there is a third division, but there are also educational rounds. Educational rounds are kind of harder than second division, and they have sometimes more interesting problems. Well, this one is just a textbook problem. So I would understand if this would be educational round, because like this is a textbook problem, and probably some of the previous ones were also. I don't remember the problems now. Yeah, that's not a textbook problem. That's like my first math problems book problem. That's just some bullshit. This is an educational problem. This one is okay, actually. I mean, it's kind of it's an educational problem on just the fact that harmonic series exists, but it has an okay statement, like kind of reasonable, and this is not textbook problem. That's okay. Yeah, this is a textbook problem, I guess. Also, it has a very weird statement, and I haven't reached G yet. But yeah, F is just a textbook problem. Like, there are problems that use this as a sub problem. Come on, how can you use it in a rated for anybody round? Like, I wouldn't be surprised if this exact problem is like on CSCS, whatever, like the judge that is like bundled with competitive programming book by that Finnish guy, whatever. I don't think it's fine to use such problems in the rated rounds. Or like at least call them educational rounds. If you have a round that is supposed to be like from main line, yeah, I don't know, mainline lineup of rounds on your platform, they should not use textbook problems. They should use novel problems. The division just defines what is the difficulty of those problems. And that is not an easy problem, actually. But like, they should be new and interesting instead of this. Doing the binary search, just as promised. Then calculating the number of operations that use like at least x. If there are at least k of them, yeah, if there is at least k of them, then it means that the border is bigger, so we need to move left border to the x, and otherwise move right border. So after I did that, we need to be careful with starting values, or at least like how do we handle the situation when you cannot do k operations that have positive values, because like that can happen and that kind of ruins our whole scheme. Like there isn't any value of x that like you will do less than k operations with greater than x and then with x, because you will just not do k operations. So after I have done this binary search, I know that I will do all the operations with at least r as my score delta, and some of the operations with L. How many? Well, k minus how many operations I did with strictly greater. What happens if not, like if I just cannot do k operations with big with positive deltas? Well, in that case, r will be 1, l will be 0, and I will say, okay, initialize answer as 0 multiplied by something. It's still 0, and that's correct. If I would put -1 here, and like there is less than k operations with non-negative deltas even, I would get that r is 0, then l is -1, and here I will say initialize answer as -1 times something positive. So like do some operations that decrease your score. We will not do that. So we will initialize as 0. Or if you want to have -1 here, which is like, it's a good general rule how to initialize borders in binary search. Like both borders should be clearly, like left border is clearly on the left and right border is clearly on the right. Like if you can initialize as infinity and minus infinity, that's great. The problem is like how do you use it afterwards? So you can put -1 here, but then you would need to write an if here. Like if r is greater than 0, then initialize like this, otherwise initialize as 0. Because like it will be a special case for a solution in the sense that there are less than k non-negative operations, so you will actually encounter this like maximum with 0, and all the operations that you have left, they will be just 0, 0, 0, 0. And like you change the rule by how you calculate the score, so you need to be careful. And I still have to think about it. I checked that my algorithm will process this correctly. The code I wrote will correctly behave in such situation. It is not obvious. Like it was achieved by setting 0 here and using the fact that it is actually 0. And so I will, well, technically it might not be true that I have this many operations that give me 0 score if I don't have maximum here. But since it is 0, I don't care what is the number here. The result will still be 0, and that's fine. That's what I want. Alright. That's enough philosophy. Here I need to calculate the answer, but before we do that, let's write function that counts the number. Like, function solve should count the number of operations with at least x. And this thing should be pretty much the same, except that we're not counting the number of terms in the arithmetic progression, but we sum them up. So if we first write this function, we will see how this should look like. And like, it's actually not a bad idea to use another function for that. Like, for example, we can call this like count, and this one would be like sum of arithmetic progressions. But since it used only once, I will, and it is quite short, I will just write it here. If AI is smaller than x, then I will not do any operation on that index, and I should say it somewhere, like either put if here, or when I will calculate the number of those operations now, which is okay, so the number of times okay, let's say the largest d such that AI minus bi times d is still greater than x is AI minus x divided by bi, and let's check that bi are positive. Right. So that's the largest d, and the number of operations I will do is d plus 1. What happens if this is not true? Well, this will be negative, and then d might be negative, and it might be smaller than minus 1, and I will say, okay, I'm doing negative number of operations. That's bad. I don't want to do that, so I wrote an if, or you can like put maximum with 0, and well, here it should be like maximum with 0 and d plus 1, but since I have this if, I don't need. Okay, so what happens here? Well, it should be pretty much the same thing. My x is r. So if AI is at least r, this is the last operation that I will do. The number of operations is d plus 1, and so I need to sum up AI minus bi, AI minus 2bi, AI minus 3bi, and so on, AI minus d times bi, and it will be d plus 1 times AI minus bi times d minus 1 divided by 2. Now it's plus 1 here. Something like that. This looks a bit scary, but it shouldn't be, because, well, we know that this whole thing is positive. So this shouldn't be bigger than this, and this clearly fits in long. Why answer fits in long? Well, because I know that it's at most k operations. Each of them were at most abelian in delta, so it's at most 10 to the 18th. Problem G. N houses and N roads. I don't like this already. This road between house I and I plus 1. Oh, okay, so they're just in a cycle. Okay, cool. All roads are bidirectional. The overseen family has gone into debt and may not be able to maintain all roads. There are pairs of friendships between the residents. If the resident living in house A is friends with the resident living in house B, there must be a path between A and B through maintained roads. What is the minimum number of roads that must be maintained? So the trouble here is we don't know which of the two paths around the circle we should keep. If we make at least one cut, then it is easy. Just for every pair of friends we're given, there is just a unique path between them, and we must save all the edges on that path. Okay, so I have a boring overkill solution. but I refuse to believe that there isn't anything better. Okay, let me talk about boring overkill solution, and then I will think more. Okay, so have a ring. We want to cut as many edges as possible, but for some pairs of vertices, they must stay in the same component. So what I said in the beginning is that if we cut one edge, then we have a bamboo, which is a tree. And for a tree, this problem would be very simple, because for every pair of vertices, they have unique paths between them, and that pair will just say, okay, we are not allowed to cut any edges on this unique path, because if you cut one, then they will be in different components. So if we cut this edge, then this pair will say that, okay, you cannot cut this edge, and this pair will say that we cannot cut these two edges. And for example, we could say, okay, let's also add something. Let's have this pair too, and then we cannot cut any of these edges. So for every edge that we did not say that we cannot cut, we can cut it. And so the answer would be just like 1 plus, like 1 for this edge, plus the number of edges for which we did not say that we cannot cut them. How to implement that? Well, we can, for example, set a counter on every edge that will say us how many times it is not allowed to cut. So for this edge it will be 0 and 1, then 2, because for this edge there are 2 pairs that are against cutting it. 1, 1, 2, and we just need to count the number of zeros in this array. And yeah, since it was a bamboo, it will be an array, and for every pair we just need to add 1 on segment. Okay, we could do all of that like offline, but that doesn't really help us to solve the initial problem. For initial problem, well, obviously we can cut one edge. We can cut any one edge because the graph still will be fully connected. So if we cut one edge and we know which one, we can then reduce it to the problem on the array, which is great. So we can try to iterate over all the edges. Like, this is the one edge that I want to cut, and see what's next. Like, what depends on where we cut this edge? Well, if we choose a different edge to cut, like this one, for example, the pairs that went through that edge before, they will now have to go the other way around. And so for this pair, we will have to not cut all the edges on the other half. But it is like, it's true in general. For this pair, for example, we will switch to this part. So if we do a scan line on where we cut this edge, the first one, When we move through the vertex that belongs to some pairs, for that pair we'll have to flip before we band like this half, now we will have to band this half. Well, okay, imagine our array where we are counting how many times the edge is bent. Every pair was like adding 1 on some segment. So when I want to, well, it's a circular segment technically, but circular segment is just 2 segments at most. If I want to flip and now bend the other half, I want to, well, unadd 1 on the circular segment I had before, so like subtract 1, and then add 1 on the new segment. The main idea here is that for every pair that we have, that will happen constant number of times. Like, there are 2 vertices, and when we move through the first vertex, we'll need to flip, and then when we move through the second vertex, we'll need to flip back. So let's say we are maintaining a segment tree over this array, which is, well, it's technically a circular array, but we can cut it's somewhere and look at it. It is a regular array, and then we have like circular segments in it. We need to be able to like add 1, subtract 1 in circular segment, which is just at most 2 regular segments. And after we do all the changes, we need to just count the number of zeros in that array. But zeros are just minimums because all the numbers are, all the elements in the array are non-negative. So we can maintain minimum and the number of minimums in our segment tree. And then the solution looks as follows. Like we have this segment tree which supports adding on segment and calculating minimum value and the number of those minimum values. Then we iterate over where to do the first cut, do this kind of scan line. When we move through the vertex, we need to flip all the pairs that contain that vertex. Flipping is just adding -1 on the old circular segment and adding 1 on the new one. And for every option of the first edge to cut, we'll ask for a number of zeros in our array and update the answer with it. That will work in linear from n plus m times logarithmic time. Like linear number of queries to the segment tree, each query is done in logarithmic time. So that is a correct solution in this time. It's not even that hard to implement, but I'm sure there must be something easier. That is a valid solution. Okay, so let's say, again, we have a problem on a line. And I want to suggest like an alternative method to understanding which edges can be cut. So I said we should like add one on segment for a pair of here and here. So if we have like a pair like this, we said like add one on these three edges. What we can do instead is we can XOR these edges, but not by one, but by something random. Let's assign a random value to the edge, like this pair, random value xi, and then we will XOR each edge by this value. Which edges can be cut in the end? Well, the ones that weren't XORed even once. Obviously they have like the initial value. Let's say that we initialize all the edges with zeros. Then yeah, like the edges that we didn't touch will have zeros. What will happen with the edges that we did touch? Well, each pair will have their own random variable. And for every edge, the value will be just XOR of all the values that we assigned to the pairs that go through this edge. And hopefully it is not zero. If we choose random n-bit value, then the value assigned to this edge will be also a random n-bit value. Unless this edge was not covered by anyone, then it is zero always. Otherwise, it is a random n-bit value, and hopefully it is not zero. And so the answer is still the number of zeros. So for some reason, instead of simple +1 on segment, I changed it to XOR by random value. So now the algorithm is not deterministic and also harder to analyze. But the reason for that is that now we do not distinguish between the ends. Like to add one on segment, if we were using prefix sums, I needed to like add one here and subtract one here. But if I'm using prefix source to calculate XOR, then I will just XOR by xi here and XOR by xi here. Then calculate prefix source, and like after the segment they will what's the word? Cancel each other. That's the word. Why is it important? Well, because now I technically don't need to choose the starting point beforehand. Let's choose some point as the starting one, do all that, calculate prefix source. Now, what will happen if I move the starting point So I'm in a circle and I'm moving starting point. Well, I'm changing how prefix source are calculated, but only by basically instead of starting with 0, I started with what was prefix XOR at this point. And since I know that total XOR of everything is 0, um, to actually if I want to change the starting point, I should just XOR everything by the XOR value here. So my answer before was the number of zeros. Now I can choose any value and XOR everything by it. By this way, I'm changing the starting position to here. And then I calculate the number of zeros, and that is the answer. Great. So the answer to the problem is just maximum frequency of any number that occurs in my prefix source. It's kind of like the same idea. Basically, by starting by selecting the starting point, I can say, okay, the next edge I will not cut ever, and so here from here I'm starting to calculate my prefix source, but how I'm calculating prefix source do not depend on where I start technically. I mean, it depends only in the sense that I start from a different value. Well, okay. So basically, I change what 0 is. And that's it. Let's try. I mean, I'm sure it is correct. Well, I can just throw them all in map. That's the number of rows I will cut, so I need to print n minus that. I'm not sure it was worth it to sit and think about better solution. I'm sure I could implement the one with segment tree fast enough, but this solution is much cooler though. And it's much shorter to implement. There's no segment tree. Oops. Okay, yeah. And problem G is also kind of educational. I'm interested though, is it educational on the solution with segment tree or educational on this very cool XOR idea? Like, both are nice enough. Also, like, you could probably do the same with adding random number instead of XOR, and just also when you choose the start, you choose what is the number that is like considered zero, but what is the number where you start calculating. But with XOR, it is more clear, and it's easier to calculate the probability of failure. How long is the queue? Okay, so it's testing solutions 15 minutes from now. So I guess I can press 5 for 10 more minutes, which is not that fun. I mean, I'm sure it's correct. There is nowhere to have a bug unless the limitations no. Yeah. I don't know what to say. It's a good collection of textbook problems. I wouldn't want to participate in that as a rated contest, but guess that's just my tastes. And what constitutes rated contest? Okay, I'm not sitting there for 10 more minutes. Thanks for watching. Bye.